Hello, everyone. Good morning, good afternoon, and good evening, and welcome to today's webinar. And this is FJD Trion Scanner Talks. My name is Alice, the Geospatial Product Manager from FJ Dynamics. So before the talk really begins, let me briefly introduce why we plan the FJD Trion Scanner Talks. So since we first launched our scanner FJD Trion S1 in 2022, we are the manufacturer of the FJD Trion scanners. But at FJD Trion Scan, we not only care about the product itself, we want to provide the whole workflow and the whole solution for everyone. And since then, we have empowered over 1,000 professionals to redefine how their workflow of capturing the 3D data. So now we want to hold a serious webinar that not only focus on the product spaces itself, it will bring you the proven workflows and industry-specific solutions straight from the field experts who use our scanner daily. So that's why we plan these talks. And so actually, we have shared the information about our activity on our social webinar. So now I wanted to have 1 minute invite all of you to follow our social media accounts. You can follow on the Facebook, LinkedIn, or the YouTube, and all the details of our activity and our guide videos will be shared there. And okay, so today we are very thrilled to have Nick from the Scanflow Solutions. And he's a pioneer in the large-scale industry digitalization. And in the next about 40 minutes, he will start to share how he used the P1 to cover the whole workflow to scan a multi-floor building, from the how to prepare and to how to check the data quality. After that, he will show how to do the DTM extraction in the Trion model software. So now let's dive into the whole workflow with Nick. And Nick, I will give you the floor.
So, hello everyone, and thank you for joining this session. My name is Nick. Next slide. Yeah, my name is Nick, and I'm the founder of Scanflow Solutions. It's a German company dedicated to delivering efficient scanning workflows based on mobile SLAM laser scanners. We are not just a distributor of FG Dynamics in Germany. Our mission goes much deeper. At Scanflow Solutions, we develop practical and efficient workflows for working with mobile SLAM scanners and making this powerful technology accessible and usable across various of industries. That's what we do for all of our customers. We believe that SLAM is for everyone, and that's why we've made our goal to integrate mobile laser scanning into real-world workflows for professionals from many different fields. Today, our clients include landscape designers, architects, surveyors, civil engineers, craftsmen, painters, scaffolding companies, logistics firms, excavators, real estate agents, and even many more. So this diversity proves that SLAM scanning can support a wide range of planning and documentation tasks when applied correctly. And that's why we are here to learn how to use this device in the most efficient ways. And today's topics are the introduction for practical SLAM basics. That's what I want to tell you. And then I will show you some strategies we use for multi-floor building scans without using control points, because many of our customers doesn't have the opportunity to capture control points because they don't have the equipment to. And many of the projects doesn't even require accuracy verifications, and the accuracy you can achieve with a proper strategy is good enough to get the task done. And second topic will be workflow to extract a digital terrain model out of a point cloud, out of a scan with the P1. So let me show you my Army Swiss knife, the P1. The P1 is a very good SLAM scanner for beginners, but not only for beginners, it is a SLAM scanner for professionals. It's a really good device where you can meet a lot of tasks with it. So here you see the P1. It's equipped with the battery grip, the base plate, the 360 camera and the LiDAR sensor, and we're using every single part of it to develop workflows and efficient strategies to get our workflows most efficient. Let's dive to what is SLAM and why route planning is crucial for the accuracy of your projects. So what you can see here are let me explain you first what SLAM stands for. SLAM stands for simultaneous localization and mapping, and it allows us to create 3D maps while tracking the position of the scanner in real time without using additional sensors. However, SLAM relies on an inertial measurement unit, the IMU, and that brings a challenge. So the longer we scan without returning to areas, to known areas, the positional error increase, like you can see here. So we have the positional error go up and time go past. So in order to minimize the positional error, we need to close loops. And as we continue scanning, the error grows. You see it in this graph here. So the error grows. And after we come back to a region that we scanned before, we get the so-called loop closure, and the position error will be minimized again, will be corrected. And then we go scanning again, the position error will rise up again. So this is the graph looking when we're scanning inside buildings, for example, where we don't have RTK corrections or corrections from other sensors. So it is really crucial to get loop closures. I know inside buildings, it is pretty hard to close any loops because you have narrow rooms, you have corridors, you then have big space and a lot of features to the algorithm to detect loop closure. That's why I developed the technique to shift the loop closures outside. I will show you later. On the other hand, we have the option to use, like seen here, an RTK antenna for the P1, where we can get permanent RTK corrections. So the position error won't get as high, but we will still need features in the environment to keep the SLAM going. So if you compare this to, you can tell scanning indoors is more difficult because we have to pay attention to the position error to minimize drifts and make sure to close loops frequently to minimize the error. While scanning outside with a fixed solution in the RTK, it is much easier to get a good result because the corrections will be applied in real time. So this we need to keep in mind for the next steps I will show you. So we can sum up some key success factors for high quality SLAM scans, and what we need to do to achieve high accuracy without ground control points or without control points is, first of all, using the RTK antenna. It is a really huge help for us. Second, keeping the scanning time short, ideally under 10 minutes per mission. And this applies for indoor scans especially. You can go over 10 minutes for outdoor scans when using the RTK antenna, but you need really to keep your scanning time short when you're working inside or when you're scanning inside a building. The third point is to plan your route well and include enough loop closures. You can imagine your scan route needs to be like a racing line. It needs to be smooth. You have to avoid abrupt stops. You have to avoid going to the same area twice in opposite directions, for example. And the fourth point is to develop a clear segmentation strategy for your scanning missions. That means when you have a multiple floor building, you need to separate your scan missions for each floor. I will show you later. And the second thing you need to keep in mind every time you use the P1 is the field of view of the LiDAR. So this is very important because SLAM depends on the information it sees. And you can see here, when you're holding your scanner, for example, vertically, like here, this is the field of view the scanner sees. So it has less features in the field of view when you're holding your scanner vertically compared to when you're holding your scanner horizontally. If you're holding your scanner horizontally, you have much more features in the field of view that can be included to the SLAM algorithm and the position calculation of the scanner. So this is really crucial. Keep in mind the field of view of the scanner. Basically, you can think about if you scan all the time, you need to think, what does the scanner sees? And keep also your features inside this field of view. So with this in mind, we can start to prepare our scanning mission for a multi-story building scan. And the first thing you need to do is make sure to know the building you're scanning. If you have old floor plans, you can take them as help to plan your scanning routes. If you don't have any old floor plans, then you have to walk through your building at least once and make sure to identify narrow corridors or hard to scan areas like small rooms. Make sure to open all doors. Make sure to remove curtains from windows in order to scan the window width and height. Like here you see there's a curtain, you can remove it, and make sure to open some windows. And the opening windows is very important for this workflow because, like I said, closing a loop indoors is pretty hard. And that's why we shift the loop closure outside. So what we do is, by opening the window and taking the scanner outside the window, we're closing the loop with the outside environment. That's why it's important to open windows beforehand. And there are also some key scanning rules. You need to separate each floor, like I said. So each floor should be a standalone scan mission. You need to start with the outdoor scan with RTK fix near the building entrance, and your first scan will be the outside scan. End each scan at the starting point to create your final loop closure. Use your scanner's continue scanning for splicing feature. If you don't know what it is, I will show you later. To start the next scan and connect it to your first outdoor scan. Then continue the first floor as planned. And if you don't feel good about your scan, just don't stop the scan, complete it, and consider doing another scan because when you arrive at the site, you don't want to process the data in your office and figure out that the data is not good. That's why when you have a bad feeling about your data or about your scan, just complete it, take another turn, make a second scan, so you have options to choose in the office later. It's easier to take another 10 minutes or 15 minutes to do another scan than driving again to the site. Then, if you have vertical loop closures, then you have to make sure the open windows, like I said, and match scan the outside area first. I will explain later why. And really important, the scanning pattern or the attachment should always be to the first scan, because the first scan will be the outdoor scan with the RTK, and it will be the most accurate one. So we want to stitch every second one to the first, the third scan to the first, the fourth to the first, and the fifth to the first. You do not want to stick it in a line like the first outdoor scan, then you have the first floor, you stick it to the outdoor scan, then you have the second floor, you stick it to the first floor. That's the wrong way. You need to stitch every scan to the first one. And what I mean by that is, I'll show you in Trion model. So here we have the scan I did of the building. And what you see here is my first outdoor scan. So this is my first scan. I can blend in the trajectory here. You can see my starting point over here. Let me display it by time. So we see blue is my first walking path. I walked like this over here, then back here, and then a wider range back here. So this was my first scan. It took me about 7 minutes, I guess, and that's it. So my starting point and my end point is the same. I had enough loop closures here, so we can continue with the next one. The next scan I did was the first floor. So this is the first floor, and let me blend in the trajectory again. So this is the trajectory of my first scan. You see, the starting point is the same, and I start from the same point. I walk indoor, I scan inside, I go back outside and close the loop. So this scan took me about 5 minutes. And then we move to the next floor. Let me show you for example, this one. Now let me show you this one, the first floor. And by blending in the trajectory of the first floor, yeah, you can see it here. So what I did here is, when scanning the first floor, I shifted 2 loop closures outside through the windows. So I started here, again at my starting point, walked the outside area to this point because I planned to open this window and pass the scanner through the window to get a vertical loop closure. So in order to get a vertical loop closure, you need first to scan the outside environment, so you have features that the algorithm can use when giving the scanner outside the window. And I have a quick screen recording how it looks in the scan app. So here I'm in the second floor. We see at the top left corner the indicator for loop closures. I have 1 loop closure. As we are inside the building, we have no fixed solutions for the RTK. And now pay attention what happens if I stick the scanner outside the window. At this point, I'm sticking the scanner outside the window. We have a second loop closure appearing here already. And you see this indicator here showing us that we have a loop closure detection from the trajectory here to down there. and we're also fixed with the RTK, so we get the corrections also for this trajectory from the satellites. And this is how you can shift your loop closures outside and do it frequently. For this huge building, I did it at this point and also at this point. So I had loop closure here and here. After scanning the outside, I had it inside to the stairwell upstairs, scanned the whole area here, got my first loop closure here, went to this point, got my second one here. So it's a really close time that pass, like 2 or 3 minutes between these two loop closures. And the third loop closure, the final one, was outside the second exit. So I had the second exit of the building over here. I exit the building and went back to the starting point. So this is basically the strategy we use to map inside buildings without control points. So our control points are basically the loop closures we do with the outside when we are walking here with the fixed RTK solution. And we do it basically for every single floor. So this is the next floor I scanned. You see, I walked upstairs to the roof, and then I have a window over here again. And you see here the green trajectory. Let me show you the rest of it. Where is it? Here remaining. So yeah. So I walked again. I started at the same point, going outside, scanning this area to ensure that I have points, features here when I stick the scanner outside the window at this point, so I get the loop closure. So this is the main idea. And to combine these, you need to use this scanning for continuous scanning for splicing features. So here you can see my first scan, and then you just hit on these 3 dots here in your scan app, and then you click continue scanning, starting from the same point again, and then you start your scan. And it's important to use always the first scan for the continue scan, like I did here. So this was my first floor. I did it. I hit the 3 dots on the first scan. Then I do my second floor. I hit the 3 dots on the first scan. This is important. So this small green indicator here shows us that this scan is continuous from the previous one. And after we scanned everything, we download the data. We process it in Trion model. And let me show every single floor here. Outdoor. I cropped some of the point clouds already. I will show you how I did it with the second floor. I left it for this webinar. And I will enable the remaining point clouds. Remaining. So you have a lot of overlapped areas here because you scanned all the areas twice, because we started every time at the outside, and we passed the stairwell twice or 3 times for each floor. And to check the data, we have but before we check, we need to use in Trion model this feature, the registration, continuous scanning for splicing registration. So in order to use it, we go with our first scan, we pick our first scan, and we pick our second one. So they're highlighted here. And then we hit continue scanning for splicing. Then these 2 point clouds will be registered. After it is done, we hit the first one and we hit the third one. again, continue scanning for splicing. Every time hitting the first and the fourth and the fifth and so on. So after the registration is completed, you'll get this messy point cloud here. And now we will check the quality of the registration by slicing it, because we don't have any control points to check it. So we need to check it by slicing it. I use the profile analysis tool. And let me just make a section somewhere near Windows. I like to do sections through Windows because you can easily see when a room has drifted by comparing it to the outside scan. So maybe let's take a section here. Okay, so we have a lot of colors here, but what we can see here is we have different layers of point clouds here. We do not want to have this in our final point cloud, so we need to clear them. But to show you how the spreading is, like when measuring the height between the lowest and the highest point, we have 1.7 centimeters. And in my opinion, it's more than enough working without control points. And in vertical, we have 1.2 at this point. And when comparing the windows, oh, this is a room I did not scan from the inside. It looks pretty good. So the layers are on point. Let's try maybe another section, maybe here. Yeah, let's try this one. And it looks good as well. So we don't have that big shifts. It's like really, really 8 millimeters here. This one aligns also well. So you see, with the correct workflow, you can get good results even without control points. Maybe let's do another final section through the staircase, because this is one of the challenging environments for SLAM. Let's go like this. Maybe we can see more misalignment in this section. You could expect it, and let's check. Let's go full screen. Yeah, so you have a bigger misalignment here. So the green line is the roof scan, so the very top level. And what I will do is I will just delete this scan, because I already deleted it because it's remaining. So if I disable all remaining point clouds, this is what I cleared up. It will look something like this. So at the end, you will have your thin lines by eliminating the other point clouds that are not that were not used for the scan. And let's measure this one too. From here to here, you have 2.4, 2.5 centimeters. Like it's still a good accuracy, still a good result you receive. Or here you have even more, 3.2. But like I told, we will delete this line, and we won't have this in our final point cloud. And the windows are looking good as well. So this is how you can check your the quality of your point cloud. And there is another way to check the quality of your point cloud. when processing the point cloud, let me just show the one I left for the webinar with the, oh yeah. So this is how the point cloud will look like when scanning outside, inside, everything. This is the raw data you get, or the process data you get. And to check the quality of your scan mission, what I do is I like to display the point cloud by time and check for, oh, let's go. Check for different colors being displayed at the same place. So you don't have layers here. And you can also use the section tool and go make some sections, for example, where windows are. For example, here. This is the window where we use to get the scanner outside, and then display the section by point color, so you can check for different colors at different places. And this one is looking good as well. You have a slightly drift here, but it's usual. This one is looking good. This one is looking good. So the windows are looking nearly perfect. It's the most you can get out of the SLAM scanner. And here you have a little drift, but yeah, it's not worth mentioning it because we are eliminating the outside points from the inside. Okay. So after you finished your scan, you processed the data, you registered it, you need to clear your point cloud. And I'll show you a simple way how to delete all the outside points, because I don't want the outside points because I have them already in my outdoor scan. So I don't want them to be doubled. So I pick my first floor scan and I go to Edit, Clip by Path. And the first thing I will do is I will clip the point cloud by trajectory. So I see I started walking inside the building this way. So maybe let's crop it from here. And I walked outside the building at this point somewhere. So I mark this trajectory here and I delete everything outside it. So these points you see here are points captured from inside. The green one captured by holding the scanner outside the window, and the yellow ones captured by holding the scanner outside here. And then I will delete all the other points. Okay. Yep. And now I use this clipping tool over here at the right. Going to the top view and deleting everything belonging to the outside scan. So this could take a minute. Maybe I can open the chat meanwhile, so you can write some questions I can answer. I don't see the chat. I don't see the chat. Never mind. Okay, I need to start this again. And you need a basic understanding of how a building is built and what belongs to a window and what doesn't, and where to put your slice. These parts we captured from the outside. So I cut them off and I have this one in the outside scan. Yeah. So this one is clearly belonging to the inside of the building because it's colored yellow. And as I walked outside the building, the color shifts to red. So I will keep this inside. Now let's make just roughly so we don't waste any time. Like this, and then I just delete all points belonging to the outside. And by the way, in Trion model, there is no undo button. So when you delete points, they are deleted. You can't bring them back. So keep that in mind. Delete. Oh, yeah. Well, never mind. So what I usually do is I will also delete this area because I have this area scanned in my indoor first floor scan, but for now I will leave it to show you the results. So now let me just display every point cloud I have. 1, 2, 3, the outdoor one as well. Outdoor. So what we get now is a clean point cloud without overlapping areas. And to prove it, we can do another section. Let's go straight across the building. Somewhere like here. And your end result will look something like this. So here you see still some double layers because I didn't delete them. So this is the second floor and the third floor. What do we have here? 2 centimeters. It's fine for this use case. This one is aligning well. And we don't have any other double layers. So here we have one more. Maybe these points are being captured from the inside of, from the outside through a window. It's also a possibility. So you basically get this. And after confirming your registration and your cleared your point cloud, all you need to do is just mark your point clouds like I did here. So you get all of them and then you hit merge. If you want to, you can also crop the outside point cloud so you don't have all the messy stuff around the house if you need it, but I like to leave it visible to have some additional context for the project. Oh, I see the chat over here. Okay, we're waiting. So what this button does is it merges all the single scans to one big point cloud. And you see it here. So this is our mission combined. And even the basement, by checking the windows, the position of the windows with the outside scan, you can see whether you had drifts in there or not. So this is the way you can work with the SLAM scanner without any control points. So this is my workflow for the preparing the data to export and scanning multi-floor buildings. And you have your final point cloud here, and then you have the opportunity to export it like you do it with your other point clouds as well. So that's it. Maybe we can answer some questions, no? Or can we do it at the end?
Yeah, I think, yeah, there are already some questions. So
Yeah.
some of them might be interested. Let's see
Yeah.
one by one.
Wow, so many people here.
Yeah, so the first,
So keeping the scanner at the same angle, the whole loop. No, I don't do it. Usually, I can show you. Usually, when scanning indoors, whether I hold the scanner like this because it's easier for me, or I hold it like this in some positions, and then I just tilt it forward or backwards. I don't do like this twisting stuff. I just do like this or like this. And one important thing is walking backwards and going slow through doorways is also important. So what I do is when I have narrow corridors, for example, I hold the scanner horizontally, and to get some points of the ground, I just tilt it a little bit, or maybe like this. Yeah. And walking backwards is more practical than forwards, because when you walk backwards, the scanner will have all the area it scanned previously visible and can stitch the new points to the scan before points. Okay, next question. Gaussian splatting, no. When scanning four-story buildings, so you don't need to exit the building when you have, for example, here, when you have your starting point here and you get your final loop closure through a window, you can end the scan at this point. Just make sure to hold the scanner outside the window long enough to get more details at the end, so the SLAM will recognize, map it well. You can actually, when you start here and have a loop closure through a window with your starting point, it's like a end loop closure, you know? So you can basically end the scan inside the building as well, so you don't have to walk all the way back again. If you have one entrance, for example. At this building, I had the second entrance here, so I used it. I used the second exit and walked just additional 30 seconds outside to get to the starting point back.
Nick, I think maybe most of them may interested in the next part, how to do the DTM injection. Yeah.
Okay.
And for the other questions, we can share at the end.
Sure. Maybe I can. I will be in the webinar for a couple of minutes later, so people can ask me their questions.
Yeah.
Whoever wants to. So let's go to the second topic. Extracting digital terrain models out of point cloud. So here you see another scan I did with the RTK antenna, so it is also georeferenced. And what you see here is an outdoor scan. I displayed it by intensity right now. This one is not colored. And the goal was to extract the terrain to use it for Revit for design of this environment. I did. So I started by scanning the whole environment for me to have, and pay attention to this area. So I did not want it to go through these bushes. That's why I left them be like this. So we have a big hole inside here, and we have no information about terrain inside here. So in order to get your terrain model done perfectly or not perfectly correct, we need first to classify, that's what I did here, to classify everything that does not belong to the ground. You can use, I show you the tools. You can use whether the outdoor classifier, but I don't like to use it because I'm working faster when I'm classifying manually. So I classified everything manually, and then I separated it by classes. So I have the unclassified. So you can classify them manually, then you pick your point cloud, and then you go extract by class, and then you have your additional point clouds appearing here. So this is what I did. Then I had my unclassified point cloud, and I used this to classify the other stuff I did not want to appear. So I classified this, and I did the same with this one. So I had the next unclassified point cloud. Let me show you it. Yeah. And then I had still some points laying not there where I wanted to be. So I did it again. Then I had my next point cloud, should be the unclassified. And then I did it again. So at this point, maybe I use the automated classificator. So I got my ground points extracted. I extracted it again. So I have the 4 times unclassified. Oh no, it's the wrong one. It should be this one. No, this one. I renamed it. Sorry, I renamed it. This one. Ground. This one. Oh. Yeah. So I get this point cloud with all of the holes here. I roughly deleted the trees and deleted the buildings and other stuff that I did not want it to appear in my terrain model. And then what I did is I picked this point cloud. I go to Edit, Triangular Mesh, and hit Triangulation, and go for the thin triangulation, because the thin triangulation type fills holes. So after you do this, you get a mesh looking like this. And this is a mesh that is, you can see it's very laggy here. So it's a mesh with a lot of points, a lot of triangles and surfaces here. And you don't want to work with this mesh in your third-party software because it will be too much. It won't handle this. So what I did here is I used this mesh to smooth it. I smoothed it, and then I sampled by grid. So I tell the software to create another point cloud on top of this surface with a grid of 0.3, so approximately 30 centimeters between points. Then I hit OK. And then I'll get this point cloud here. So it's a much lower dense, not so dense point cloud, but still accurate. Let me display it by the elevation so we can see it. Yeah. So we have still our elevations here, and you see the holes not filled before here are filled now, estimated. You see? So we get this point cloud, and now it depends on what output you want. You can triangulate this one as well. So you go to Edit and go Triangulation and do it with this point cloud. So you get something like this one. So this is a much smaller digital terrain model you can work with in third-party software pretty well. It is handleable for your PC. So this is what you can do, or you just hit, and that's how I do it for Revit. I hit export and export it as ASCII cloud in a TXT file. And the export will look something like this when you open it. So you have your positions here, the X, the Y, the Z, the coordinates. And then you have some additional informations stored in these lines. So this is the intensity stored here, the RGB and other data. And for Revit, we just only want to have the X, the Y, and the Z separated by comma. So we need the CSV the file at the end. So separated comma value. And to achieve this, I use Notepad++. I hit, wait a second. I hit strong H, and then we can, you can use Excel as well. It doesn't matter actually. Just can't find my, let me try this. Yeah. And you hit OK for everyone. And then you have your new file here. You save it. Ready to use for Revit. So, no, it's not ready to use because you need to not to use space, but commas. But you can do the formatting in Excel as well. And you save the file, you rename it as CSV, and import it into Revit. And let me show you how I use this terrain model in Revit. So here you can see my point cloud, and this is the output I get in Revit. And as the terrain model is georeferenced as well as the point cloud, I import the point cloud and the terrain model into Revit with a shared coordinate system. And then I have them laying at the same position. So I can, for example, get to the top view, display the point cloud by intensity, and add in Revit the roads here, for example. So this is how I create this simple terrain models for Revit for my visualizations or for projects I do. And later on, I use this model to create visualizations with a perfect terrain model. And this is the area where the trees were before. This is the area where the trees were before. And I have an roughly accurate terrain model that I can use for my projects to do such visualizations right here. Okay. So I flew over this topic